Continue with this one. It'd be 1 over 6 squared. I'm sure you're good with that. And then 1 over 36. Yeah, 1 from them 28, 25 for sure. And this one. Okay, this one. Now, there's two ways of doing it. Number 26. Two ways of doing it. One way, now I'll show you. One way you can do it like this. I wouldn't do it though. One way is like I convert it, to the form that's non-negative. Then, I'll write it on top of each other and then I'll subtract. I'm not going to do that because this is very short. You just go ahead and subtract this together, right? Side by side. You subtract it. Now, careful though. Oh, wait, I'm sorry. Add. But in the end, it'll be 3 to negative 4. You can show this work, but some student would jump right to the answer. It'd be 1 over, or this form at least, jump right here. And then you could just go ahead and do 81 here. So, but I recommend you do all the work like this so that you show all the work and you know exactly what's happened. Again, this can be done differently. You can do it like this, and then you subtract. You get your 1 over 3/4 like that. Look at that. Look, if you were to do it this way, and then you can say 1 over 81. Same answer. Is that okay? You see that? Remember, you use your imagination. The bottom is bigger, so just go ahead and imagine that you subtract. It's down there. It's 4 left on the bottom. 3 to the 4th. Right, this one. Since this one doesn't have any negative, you can just go ahead and do 2 to the 5th or 32 if you know it already. Like 2 to the 5th is 32. 2 to the 4th is 16. 16 times 2 is 32. But I'll write it like that for now. You know what? I'll write it on the side because it'll be 2 to the 5th. Like imagine you do that on the side. It'll be 32. And then M25 and 55. Hope you're okay with that. Yeah, I would do something like that. If you were to do a negative, you could like that. You can write the negative on the side and then bring it down back for the final answer. So you can skip this. You can skip this row if you want. But I have good confidence that you're okay with that negative with the parenthesis and all that. Okay, this one is good one. This one you do 1 over 7 to the 3rd. 7 times 7, 49. Use a calculator. You can do a vertical multiplication. Okay, so 3, 4, 3. Oh, your teacher allows you to use a calculator. So yeah, this one again you can do it differently. I'll do it this way now. I'll do it 5 over 5 to the 5th, and then I'll do 1 over 5 squared and 1 over 25. But there. Are you okay? It's like subtract that from there too. Yeah, I'm sure you get there. But something like this in the future, you're like snap, 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 snap. You're still going to see it like this too. Or you can still subtract, add them like that in the, side to side, and then bring it down. You got to be flexible here because, there's so much you can do here differently. Okay, I imagine I bring this C up to a 7, then I subtract 4. I'm shortcutting it now. You see that? Yeah, I just do that. And then it'll be C to the 3rd. I shortcut another C next to it, minus 4 next to negative 4. Same thing with this one. Go over to shortcut it. It'll be Y positive 10, and then I'm going to add negative 6. I'll emphasize negative 6 like that, and then it'll be Y to the 4th power. You can do minus 6, okay? But there. And then this one, it should be 7, dude. We just did the math back here, right? Yeah. So it's basically, hey, what times what times what? 3 itself 3 times. It should be 7. And I did that in the calculator here. Hope you're okay? Right there.
Yeah.
So this one should be 2. Like 2 to the 4th power, or 2 times 2 times 2. Some teacher, have you show the work looking like this? I don't know. Because you have to use exponential property for it. Sometimes the teacher have you write it like that. So I'm just going to write a bunch of things here. But I think you can write when you write 2, it should be fine. This one, 3 to the 3rd power, or 3 times 3 times 3. It's 27, so therefore the answer is 3. I think your teacher will be okay with that. Okay, now, conversion from exponential to radical form, root form. All right, let me see. write the expression and write it. Okay, so it says just to write it and you don't have to simplify it. Okay, tell me this one, 36, number 36. Okay, what do you think? Eight,
Is it just
18 to the 1/2 into the radical form?
yeah?
Or how do you write it? I want to see what you know.
So I'll do like the radical sign,
And 18, right?
and then yeah, and then 18 inside it.
You okay with the denominator being here, but since this is a square root, you don't have to write the 2, right? You okay with that? Yeah. Your teacher
Yeah,
mentioned that, right? Yeah. Okay, now,
yeah.
what about 37? Careful, and this one is a
So
little fancy. Let me see. Go
yeah,
for it.
so you do the radical sign,
Uh-huh.
and then the 5 on the outside and the
Good.
R on the
Good
inside.
job. How do you know that? Because the R is only R is raised to the 1/2 power, right? Yeah.
Yeah, yeah,
This one they do it on purpose. That a lot of some of you guys, I don't know, will put the 5 in there. That would be wrong. Yeah, it's on the outside. Now for it to be inside together, then they have to parenthesize it right here, right? Like 5R, right? Like that. Yeah, you got this,
yeah,
dude. Yeah. Yeah, you got it. Like this one, you already written it. Like this one, yeah, they're together, so you can bring it out like that. Now this one can be written further. Let me show you. But I think you're good. I think you're good here. Your teacher, you should be fine if you want to leave it like that. But let me, yeah, good job there. Yeah, this one you can also, I'm sure you're okay stopping there, but you can also write it like this if you want to. Get it? Like that. Yeah, you didn't know. Yeah, I think you do. It doesn't have to have a fraction. You've been doing like the set squared and all that. You bring it in. Remember, we've been writing that in. So that's why you can bring in the half also for the 19. Get it? Like there. Again, I think you should be fine here. And what about 40? I know you're going to write 13 on the outside.
yeah.
And what about the root? How would you write it?
And then it would be, I think it's a 3 and like the little,
Yeah. Yeah.
the, yeah, and it's,
And then AB
yeah,
inside.
and then TV on the
Yes. This is called, if it's like fourth power, a fourth here. Anyway, if it's 3, it's a cube root. If it's 4, it's a fourth root. I'm sure there's a name for it. Anything like starting at 4 or 5, you just say like fourth, fifth root and all that. They also call this an index number, like the wedge in between the wedge. I guess this is the wedge right here. So they call it the index number is 3. But you can say root number, like third roots, 2 root, 3 root, whatever. But yeah, you got it. This is the answer. All right, let me see this one that you. Oh, I see. Yeah, that you have to do. Okay, 41. Plug in, right? So you're gonna plug in 41 here. Plug in the 2. Check it out. If you want to be clean, you could just write something like this: 2.3 to the third. Now there's more fancier notation with the bracket and the parenthesis to emphasize you plug in, but you guys are not going to do that. I think you just do this, and then it'll be 6 to the third. 16. Oh no, 6 times 6, 36. 36 times 6. I don't know. Just punch it in. 6 to the third. 216. You can do the math there. Okay, 42. Be 2a. Now, some of you guys will write the dot. I recommend you use the parenthesis here, like dot 3 without the parenthesis, and then raise it to the second power. I recommend you do it this way because it might look weird, like 2.3 looks like 2.3 squared. Get it? Sometimes this point can be too low. Now, yeah. So I recommend you write it like this. So it's going to be 2 times 9, 18. The order operation, got to do exponent first. 18 there. Double check, yeah. Now, 43, C. Careful on this one. The negative that you have right there, it's independent from your negative from here. So you got to keep that negative in the front. And here's where the parenthesis is going to be pretty important here. You should use the parenthesis now, right behind here. Again, this negative is this negative here. But the negative, the C is -6. So that's why you emphasize, yeah, remember I've been telling you, like if you're ever gonna plug in a variable being a negative, please put the parenthesis around it, because this is going to be something important later on. And it's kind of important now. Yeah, you cannot afford to make like the sign error. If it's raised to a third power, it will be negative. If it raises an even power, it'll be positive. Right here only though, okay? So right now, this is the work that you show. You should always do it for a habit. It will save your butt for something way more difficult later on. At least you're hearing me out here, because this is gonna save your butt for calculus and beyond. If you're gonna go and do more than that, so it'll be -36 finally for the final answer. Yeah, that's 36 came from here. -6 times -6. So the final answer is with the negative in the front. 36, -36. Now this one is written even fancier. Let's have a look. So it's 44, number 44. I know I've been parenthesizing, like that's how I've written it. Sometimes I circle the number that I'm going to work on. Okay, now careful on this one. How do you even do this? Now you haven't learned how to punctuate, like parenthesis inside a parenthesis. It's okay. Just go ahead and do another set of parentheses inside it. So this negative is this negative here. But the C that you're about to put in, it's also a negative. So you emphasize it again, put another parenthesis there. These two here are the original parentheses, but you have a new inner parentheses. Now this thing that I just did, wrote like this, it's in coding, in computer programming, but they're not going to have a big parenthesis or anything. I think they can. They have this particular workbench. There's different names, like things that they work on, right? Like the background that you put in the information. Sometimes they emphasize by coloring, like show you, hey, the color is this outer color is blue, the inner color is red. Sometimes they make it bigger. In math, they bracket this. They turn the original into a bracket, and then what you put in, you parenthesize. You see that? Now you may not care for this. I mean, some student don't care for this, but it will help you for different things like coding. Like I said, like programming. You want to program, this will be extremely important. So anyway, continue here. Now you could kind of simplify the inner parenthesis in between these parentheses. So if you simplify inside here, it'd be +6. You don't have to write the positive symbol, and then you show the work. The final is 36. There you go. Again, some of you guys will not do any of this punctuation. You guys imagine it inside, right? Hey, it's a negative C, but a C is negative. Therefore, it's -6. Therefore, it's +6. Some of you guys would jump right to here. Get it? And even without the parentheses, just 6 to the second power. Fine. But right now, I want to show you what's happened, in exactly step by step. And yeah, it will be something that you can do in coding and in later math when it's something way more fancier than this. But okay, same thing for 45. I'm going to emphasize the same way. It'll be a negative. This negative is this negative. But the C that you have is -6. Okay, here it is. But then close the parenthesis. This one here. I made them bigger so to discern, to make them different than the original. Than the one inside. It's literally the original. Is that okay? They're the original. Raise to the third power. And then continue here. This here, see, I'll bet anything. Check this out, dude. If you do 45, now I assume you copy this perfectly. If you do 45 without showing the work, some work, I'm gonna guess many of your classmates, up to half the class, will get this 45 wrong. The answer is like you probably can put negative. Whoever put the negative would be wrong. And so the teacher or wherever you get these problems from, actually it's continuation of these, I think, right? Yeah. But anyway, if you continue, it will be +6, and then the final answer be not 36, of course, 6 to the third, whatever that was. We had it before. Yeah, 216, 216, +216. There it is. Yeah. If it's written exactly this, imagine that order operation. Just think of it. Hey, you want to do shortcut? You put a negative inside the c, it become a negative, -6. Therefore, it's +6. +6 raised to the third power is still positive. That makes sense? There, you're doing the order according to order operation that you've been doing. In PIMDAS, if you want, you can inside the parenthesis there, and then exponent. Then you're done. Yeah, PE, PIMDAS from PE. You don't have anything else. All right. This one, 46. So 46. I know I put the arrow there. 46. A negative. This negative is the original negative, and now you're plugging in a -6. I recommend again parenthesize that. This is your own work. You punctuate this yourself. The -6 with the parenthesis around it, and then raise to the third power. All right, check this one out. It's pretty interesting. So I recommend you write exactly this so that you will get the answer correct. So we check it out, okay? Here, this negative stay negative all the way through the beginning. So work innermost first, like the closest thing. You're going to exponent now. So it's -6 times -6 times -6. Now remember, if you just to eye it right here, okay? So eye that. A negative raised to an odd power, it's negative. But you can still think -6 times -6, it still will be negative. But imagine you raise to higher power, it'll be too much thinking, right? So just third power is fine. So therefore, the answer is still negative. So it's going to be -216. Was that right? The 6 and 6 is 6 three times? Yeah, there it is. Wait, before I continue, are you okay so far? Like, yeah, and then the final answer is positive, dude. So this one, it seems like it's all made up. No, not made up. Made it perfectly so that you can compare to the ones you've done before. So I like these ones, like 40 whatever, starting at the negative c, the c -6. There you go. Yeah, these one are good. So you can see the difference. That's why like the punctuation is going to save your butt. This is it. This is it. So you get to see the example why you should be doing it, at least in the beginning, right? All right, next one here. I need to arrow that. 47. Right, 47. C is -6. Again, punctuate with the parentheses, dude. I'll write the parentheses. Now, you don't have to for this one. Now, let me explain why you don't have to do for this one. If it's the very first number and not raised to a power, not raised to any power, it's the very first number in the front, you don't need to do it. You don't need to parenthesize it. And this is kind of standard in punctuation in math, if you didn't know. So I'm telling you, if you didn't know. Now, it will be different if it were parenthesized here. Like, I'm sorry, for number 47. If you parenthesize and raise to the fourth power, then you better punctuate. You should, at least until you're comfortable with it. Like the first C, you know. But right now, the C is on its own in front of the A, timing the A to the fourth power. Therefore, you don't need to write the parenthesis around it if you don't want to. But I'm going to do it anyway. Yeah. So therefore, it's and then A will be 3. This here, you don't have to parenthesize. Just do 3 to the, what is that, fourth power. There you go. If it without, it will still look nice. Look at it. See? But it's a dot. It's okay. But make sure your dot is, is in the middle right there. So with or without here, you can look at it. But it better be in the front. It better be in the front here. But anyway, I'm making a big deal, right? But it's still good. Okay, now continue. Do your math. Do the math here. What is that? 81. So it's 81 times -6. Now, what's so great about this is that if you parentheses, it still implies multiplication. So you don't have to put a dot if you don't want to. There you go. That's a good reason for having the parentheses also. But I'll put that and I'll put the dot to emphasize it. But you don't have to. So what is 81 times 6? Final answer. -6 times 81. 486. -486. There you go. I double check my math here. C being negative in the front, A being raised to the fourth, yeah. 3 to the fourth, 3. A is 3, right? Yeah. 81, yeah. Okay, looks good. All right, 48. So is this,
That's
is
a
that,
C plus A.
what is that again? I'm sorry. Alex, what?
I think it's a C plus A to the third power.
Oh, okay. So C plus A. So that means it's a -6 you can always parenthesize a negative number for a habit. There it is, -6 plus a to the third. You don't have to parenthesize this if you don't want. It's just kind of, it's just by itself, dude. It's positive also. You don't have to. You could, if you want. Look, I know I keep preaching it. In substitution, like when you have variable that you plug in, you can always parenthesize every single variable that you plug in or substitute. That is to, you can punctuate all of it, parenthesis around it to emphasize you plugged it in. So you don't want to look. Again, it's not a big deal. But if I parenthesize this, I've shown you that I substitute the two numbers. If I don't parenthesize it, it looks like I only substitute the -6. See? So there's grammar thing in math. Like, like you may not think about it. You might not even, but yeah, if you do parenthesis for a habit, you'll train yourself to think that I plug that sucker in, like however many, right? So this one, I've been trained. If I saw this, right, I would think it's only -6 being plugged in. So, but I'm just telling you, but you don't have to because it's not long. Had it been longer, maybe it's third power. Sorry, third power. So you don't have to parenthesize this 3 right here. You don't want to. Is it third power, right? Yeah. Okay, let's continue. This -6, I don't need to parenthesize anymore. I showed it already that I plugged in, so I take out the parenthesis, but this is going to be 27. So the answer is 21. Final answer. Okay. All right. And then 49. All right, 49. 2c to the a power. Is that right? I think,
Wait, let
right?
me.
I'm sure, yeah,
Wait,
they do this.
can I just check for a second on the assignment?
Yeah.
Maybe.
You were like, it looks weird. They do write problems like this, dude. They do. And I'll bet it is. I think it is. It's 2c. I don't want to bet. I don't know for sure, of course. But I think it is. 2c to the a power. This would be cool. But it is. And they have this all the time. Even like a student, a level below you has it already. I'll show it to you if you want to see it. A student class level below you is already doing it. And a root, in a root form. What? I'll show it to you right now. If I can find it. Just look at this. See right there? He's a level below. He's not even able. I know it says algebra because it is a set that taught algebra. But look at the root, dude. All the numbers now already. I think it's not, but he's doing a lot of work. Anyway, so
Yeah.
it is.
That is to the.
Yeah, it's right. So two. See, now you should be parenthesizing it. See, this is very important. So do a habit for all negatives, dude. So C, be -6. A is 3. Here it is. This is perfect, I guess, show of work here. All the way you need for this problem. You want to do more, you can do it here. But you don't need to continue here. Order operation says do PIMDAS. You don't have to, it says P, right? No. P means like if there is something you can do in parentheses. No, you can't. Therefore, you go to the E. So this is E now. If PIMDAS in parentheses is like P, do the work if there is a work that you can do between the parentheses. You don't have it. It's just a -6. So it'll be a negative for the answer here. -6 to the third is -216. So here it is. I still keep the parentheses to emphasize that you're going to multiply it to that number because it's a negative number. So I hope you understand this. Okay. Yeah. I did -6 to the third, which is -216. I need to keep the parenthesis to continue emphasizing that I'm multiplying. If you don't, it'll become a subtraction problem, right? You see that? Unless you do a big old dot here, but it's awkward. Yeah, a dot and the negative, it's awkward. That's why the parenthesis is good. It's very good for emphasizing multiplication. Yeah, that dot is awkward. If you don't have to, don't do it. Some of you guys will do it though. You still to get the correct answer like this. Some of you guys will do that. I don't recommend you do it. It's very awkward looking. Look at that. A dot minus, very awkward. But people do it, even teachers. Anyway, final answer is what? 432. Oh, negative. See? Look at that. Sorry, dude. It's negative 432. There you go. All right. Okay, is that it? I think.
Yeah, I think that's it.
Okay, let me skim through. Now I know you already checked this, but I want to see like the work that you kind of show. Hey, so to me then, therefore, you're not supposed to use a calculator. So I'm seeing all the math that you're doing here. Is that right?
Yeah. Yeah.
But what is the answer for 16 here? It's like 5,4 right here, 5,4,000, right? And
Yeah.
are you sure you're supposed to do the? Oh yeah, completely.
Yeah.
Wait. Completely is for not 5 to 8, and also oh
Oh,
I see. Yeah,
but there, yeah, it still says
yeah.
simplified.
So completely, I see. I don't think they thought this through. I have a feeling they actually copy and paste it, like and then get it like from somewhere else. And yeah, there's this math program that basically do all the fonts that you've seen so far. If you ever wonder, if you look carefully, these fonts are actually kind of specialized. It's not exactly what you see in like in grammar books. If you look carefully, okay. There's symbols. Don't forget, there's also symbol root and things. So they don't have that stuff. Things tend to tilt italicize a bit. But you can still generate that in Microsoft Word, all those word processing. There is this thing that in Microsoft Word, there's a section where you can actually do math. What do you call it? I forgot the term. Like you can make them print math symbol wise too. There's like it's like a programming code. Like certain ones they call latex. I know it sounds weird. Latex. It's literally spelled latex with the X. Latex. It's abbreviated for standing for something. I don't know what that is, but let me see here. Okay, yeah. You're cool, dude. It's minus minus. It's plus. That's fine. You kept it in the parentheses. But yeah, what is that? It's going to be 3 squared times 5 times over 7 squared. Look how quick I can do this, right? I can look at it. Wait, do you see what? Let me do it again. Number 12. I just want to see it for this one, and we'll call it. It'll be 3 squared on top, 5 on top, and then it'll be 7 on top squared. Is that it? You see how I see that? Yeah, you're okay, right? Because the top are all higher. That you subtract and keep it on top. Or imagine whatever you need to cross them out. The bottom, take out the top, the threes, the fives. I mean, the 5, the bottom here, and the 3 sevens on the bottom. But anyway, I guess that's the math that you do for this one. Yeah. Hey, can I ask, why are you doing a bunch of sevens here? Where is this one coming from? Are you
Oh,
looking at here?
so what happened was like, um, so like first I was doing it one way, but then I
Okay.
realized it was wrong the way I was
Yeah.
doing it. So then I did it like the right way.
Got it. I see. Yeah.
I
Yeah,
just
I
like
get it.
forgot to erase it.
I get it. Yeah. So yeah, you at the time you weren't thinking like the property for exponents, right? Like the thing combining exponent. No, believe it or
Yeah,
not, if you were to do the math, like multiply it all out, and then do the math on the bottom, multiply it all out, and then do long division, it will give you the same answer. You believe that, right? Yeah. Yeah.
yeah.
No, yeah, I get it. I get it. All right, dude. Looks good to me, but let me see it. Yeah, just the work. I know you already checked it, but yeah, it's all good to me. Yeah, same thing with these ones. Let me write it quickly without looking. It'll be -2. I'm glad you parenthesized that, dude. Very good. To the negative. Yeah, don't. Some of your, you believe me, right? Some of your classmates will not do it, even at accelerated honors, whatever that you guys are. I think it's accelerated, right? Yeah.
Yeah.
So even then, there'll be still be student who actually will be writing without the parenthesis right here. So let me see here. 3 third and 5 squared. Yeah, you got it, dude. And just do the math. Good. -8 here. Good. And so forth. 27 and 25. Yeah, I see it. I would have done exactly the same. Except I would have punched in the calculator. I mean, your teacher probably I don't know, on the test, on the quiz, will you be allowed? I don't think you'll get this big of a number. Okay, anyway, if you're going to do quiz, I don't think you're going to get this. I have a feeling you're not going to get it. If you are, you said leave the answer as like, you don't have to multiply it out. No, not without the word completely. That's my guess. But are you going to be allowed to use calculator? No?
I don't think so.
Okay, yeah, it's okay. All right, Alex, we'll call it then.